Hello, I'm Sebastian. Welcome to 9 Trees podcast. Today, I will summarize and review the book. Helgoland, Making Sense of the Quantum Revolution by Carlo Rovelli is a guided tour through the ideas that shattered classical physics and reshaped how science thinks about reality. Rovelli, a theoretical physicist known for making complex concepts approachable, uses the historic setting of Helgoland, the North Sea island where Werner Heisenberg made a key breakthrough, as a doorway into the early quantum revolution. Rather than treating quantum theory as a bag of formulas, the book focuses on its conceptual meaning, what it implies about measurement, objects, and the role of relations in nature. Rovelli connects foundational physics with philosophy and intellectual history, showing how quantum mechanics challenges common intuitions about particles having definite properties at all times. The result is a narrative that blends scientific explanation with human drama, tracing debates, paradoxes, and the continuing struggle to interpret the theory. It is written for curious readers who want clarity about why quantum mechanics is so strange and why that strangeness might be telling us something deep and coherent. I will give you key takeaways from this book. Firstly, Helgoland and the Birth of a New Physics. Rovelli opens with the historical and human context that led to quantum mechanics, emphasizing that the theory was not born fully formed but emerged from crisis. Classical physics could not account for atomic spectra, stability of matter, and other stubborn anomalies. The narrative centers on the intellectual leap associated with Heisenberg's work on Helgoland, where the focus shifted from imagining electron orbits to describing what can be observed in experiments. That change marks a deeper philosophical pivot. Physics becomes less about picturing hidden mechanisms and more about organizing relations among measurable events. Rovelli uses this episode to highlight how scientific revolutions often involve changing the questions, not just finding new answers. The early quantum pioneers grappled with uncertainty, discontinuity, and probabilistic predictions, unsettling the deterministic worldview that had dominated since Newton. By tracing these developments, the book frames quantum theory as an achievement of conceptual reorientation. The point is not merely that atoms behave oddly, but that our language and assumptions about what exists may need revision. The historical thread also introduces competing attitudes, from pragmatic calculation to demands for a clearer ontology, setting up the interpretive issues that the rest of the book explores. Secondly, the core quantum lesson. Properties are not absolute. A central theme in Helgoland is that quantum mechanics undermines the idea that physical systems carry definite, observer-independent properties at all times. Rovelli explains the practical content of this shift through familiar quantum features such as superposition, uncertainty, and the dependence of outcomes on experimental arrangements. Instead of picturing particles as tiny balls with fixed attributes, quantum theory describes a range of potential outcomes, with probabilities that depend on how the system is probed. This does not mean anything goes, but it does mean that what can be meaningfully said about a system is tied to concrete interactions. Rovelli emphasizes that measurement is not a magical act performed by a conscious mind, it is a physical interaction that creates a correlation between systems. The result is that statements like the electron has this position or this momentum need a context specifying the relation in which that statement holds. By stressing contextuality, the book aims to dissolve some popular paradoxes that arise when classical expectations are imposed on quantum phenomena. The takeaway is a disciplined kind of realism. The world is real and structured, but the structure is relational rather than built from objects carrying intrinsic, standalone properties. Thirdly, relational quantum mechanics as an interpretation. Rovelli is known for relational quantum mechanics, and Helgoland presents it as a way to make sense of the theory without adding speculative new physics. The key idea is that the state of a system is not an absolute description of how the system is in itself, but a bookkeeping device, summarizing how it can affect another system in interaction. In this view, different observers, understood broadly as any physical systems, can give different accounts of the same event because they have access to different correlations. That sounds radical, but Rovelli argues it matches what quantum formalism already implies and avoids the need for a single privileged perspective. The interpretation aims to keep the successes of quantum mechanics while treating the apparent contradictions as artifacts of demanding an observer-independent narrative that the theory does not support. Rovelli contrasts this stance with alternatives such as many worlds, hidden variables, and collapse models, focusing on conceptual economy rather than technical rivalry. The relational approach also links naturally to modern physics, where fields, information, and interactions take center stage. Importantly, it is not a denial of facts. It is a claim that facts are about relations between systems. This reframing, Rovelli suggests, restores intelligibility by aligning ontology with the operational core of quantum theory. Fourthly, from physics to philosophy, why relations may be fundamental. Beyond explaining quantum mechanics, Rovelli explores why the relational perspective resonates with broader philosophical traditions. He draws connections between the quantum revolution and ideas in empiricism, structural realism, and approaches that treat relations as primary and substances as secondary. The book situates quantum puzzles within long-standing debates about what it means for something to exist, what counts as knowledge, and how language maps onto the world. A recurring point is that the intuition of absolute properties comes from everyday experience at macroscopic scales, where interactions effectively stabilize descriptions and hide quantum contextuality. When we push into the microscopic domain, the scaffolding of common sense fails, and philosophy becomes a tool for reorganizing concepts rather than an abstract add-on. Rovelli also emphasizes humility. Physics has repeatedly shown that naive metaphysical pictures can be misleading, from Earth-centered cosmology to the abandonment of absolute time. In this light, the relational lesson of quantum mechanics fits a pattern of learning to describe nature without insisting that our habitual categories are fundamental. The philosophical discussion is used to clarify, not mystify, and it helps readers see quantum mechanics as a coherent worldview option rather than a collection of paradoxes. The broader implication is that understanding reality may require prioritizing networks of interaction over isolated entities. Lastly, what the quantum revolution changes in how we think about reality, Helgoland closes its circle by asking what, practically and intellectually, follows from taking quantum mechanics seriously. Rovelli argues that the most important impact is not only technological, though quantum theory underlies modern electronics and much of contemporary science, but conceptual. The book frames the quantum revolution as a shift in what counts as a complete description. Instead of a God's eye view listing absolute facts, we may need a mosaic of partial perspectives tied together by consistent relations. This can be unsettling, yet Rovelli presents it as liberating. It replaces the demand for an impossible absolute account with a picture that matches how science actually works, through interactions, experiments, and cross-checks. He also highlights that quantum mechanics is not merely about humans and laboratories. It is a universal theory about how physical systems in general influence one another. The relational stance encourages readers to reinterpret classic quantum thought experiments as lessons about information and correlation rather than supernatural observer effects. Finally, the book points forward to open questions, especially around unifying quantum mechanics with gravity, without promising easy closure. The revolution, in Rovelli's telling, is ongoing. Quantum theory continues to guide both physics research and the philosophical effort to build a clear, non-classical image of the world. In conclusion, this book suits readers who want more than popular science buzzwords and are ready to think carefully about what quantum mechanics actually says. It is ideal for curious non-specialists, philosophy-minded readers, and students who have met quantum ideas in passing but feel the meaning is still hazy. Rovelli's strength is showing that the famous weirdness is not a license for mysticism, but an invitation to revise assumptions about objects, properties, and measurement. By adopting a relational lens, readers can gain a cleaner mental model that reduces confusion around superposition and observer dependence, while still respecting the theory's experimental success. The benefit is practical in an intellectual sense. You learn how to hold complex ideas without forcing them into classical categories, a skill that transfers to other domains where perspective and context matter. Compared to similar books that either stay at the level of anecdotes or dive into heavy mathematics, Helgoland offers a rare middle path, historically grounded, conceptually ambitious, and readable. It is worth buying because it provides a unified interpretive thread, connecting physics to philosophy in a way that helps the reader build lasting understanding rather than collecting isolated facts. If you would like to support Carlo Rovelli, you can buy the book through the Amazon link I've provided in the podcast description. After reading the book, please let me know what you think and share your thoughts. See you around.